Okay, so I would like to do 46 and 14.5, which is find the equation of a tangent plane to the surface x squared plus y squared minus xyz equals 7 at the point 2, 3, 1. Okay? And they want me to do this in two ways. What are the two ways I could approach this problem?
Big F of x, y, and z, and z is equal to f of x, y.
Okay, so I could look at this thing and think to myself, this is some function of x, y, and z, right? Which is equal to some constant k. Like that would be, this stuff is the constant, I suppose specifically 7, right? Or I could like fiddle this about, right? Like do some algebra and get z equals some stuff, and then think about z as f of x and y. You guys follow that? What did you get when you did the algebra?
Well, I didn't understand how you approach it two different ways.
That was part of the hang-up?
Yeah.
Okay, so shall we approach from the blue way first and then we'll do the other way? I think blue way is part A. Yeah. Okay, so let's approach from the blue way. So how do what did I tell you guys that was helpful for this? Did I tell you anything that seemed helpful for this?
Let's see, you said it's equation of a tangent,
Yeah, okay, so hang on, let me sketch some stuff that I know. Planes have equations that involve normal vectors, right?
Yes.
You take a normal vector you got with some displacement vector and you get 0. Right?
Yeah.
That's a way to write the equation of a plane. Okay, so if I could conjure up a normal vector, I could write this equation, maybe. You guys see that? I need two pieces of information here. So I have some kind of this surface thing, right? And there's some point in here, and there's a plane that seems to be tangent to that. And I'm looking for this thing that sticks straight out of the surface. That's my normal vector. You guys all good with that? All right, so what in the heck was 14.5 about?
That one was, it was like tangent planes or something in space, differentiating functions of
Yeah, so it wasn't tangent planes, it was gradients.
gradients.
So what's the usefulness of a gradient? What's a gradient perpendicular to?
It's contour.
Yeah, a gradient's perpendicular to the contours, right? It points in the steepest direction uphill, right? So what uphill means in this place is a little weird, right? I mean, it's just the biggest climb in the response variable, right? So I have 3 x, y, z inputs, and I'm saying, which direction would you go in to get the biggest bump in f of that? That's perpendicular to this contour line. Well, this isn't a contour line, right? It's a contour surface, right? And I need something perpendicular to that, thank God, right? Otherwise the gradient wouldn't be useful at all. So I should probably just calculate the gradient of that. You guys see that? So let's just calculate the gradient of f. It's going to be a function of x, y, and z, right? Well, it's going to be kind of a bizarre function, right? It's like a vector-valued function of x, y, and z. But there's inputs, they're x, y, and z. There's an output, it means some damn thing. So how do you calculate the gradient? Okay, so and remember, all I'm talking about here is the left-hand side of this, right? Why don't I care about the right-hand side?
Always in 0.
Yeah, this isn't part of that function, right? That's just telling me which level I'm on for the function capital F, right? Okay, so I take the partial with respect to x. What do you get?
2x minus 1?
2x minus yz.
2x minus yz.
Oh,
Beautiful. And when you take the partial with respect to y, you get 2y minus xz. And when you take the partial with respect to z, you get
Negative xy.
very close. Negative xy. And that's all a vector, right?
Yeah.
Okay, so this is the gradient everywhere. But where do I care about that normal vector at?
At 2, 3, 1.
At 2, 3, 1. So let me just slap this guy with a evaluated at 2, 3, 1. And slap this guy with a evaluated at 2, 3, 1. And so what do I get? This step should be arithmetic, right? Which is why you're all hesitating so strongly. So I think I have 2 times 2 minus 3 times 1.
Which is 1.
Which is 1. And then I have 2 times 3 minus 2 times 1, which is 4 probably. And then I have minus 2 times 3. So I got negative 6. Okay, so that's my normal vector.
And then you would multiply that by, be like the displacement?
Yeah, so I need a displacement vector, right? So that should be a vector that goes from the point 2, 3, 1 to some other point in the world.
Yeah.
Right? So you do that as
X, Y, and Z minus your point.
perfect. So you take your 1, said 1 and wrote 4. 1, 4, negative 6, right? And you need to dot that with the vector x minus 2, comma, y minus 3, comma, z minus 1. And set that equal to
7?
0.
0. Why 0?
Oh, right.
They're all 0, right?
You want to be
So,
perpendicular.
yeah, dot product, right, between two vectors is 0, is the same thing as saying this vector is perpendicular to that one, right? So that's me taking my 2, 3, 1 dot in my plane, right? And some other dot someplace, and saying the vector that goes from 2, 3, 1 to that some other place has to be perpendicular to the normal vector. You guys see that? That's what that normal vector means in terms of a plane, right? It's the vector that's perpendicular to everything in that plane. You guys cool with it?
Yeah, this was the part that I
Okay.
understood. It was the other one that I got confused on.
Okay, cool.
Part B.
All right, so I got that. Now, the other way, you do some algebra, and you get z is, I don't know, like 7 minus x squared minus y squared divided by minus xy. Right?
Sure.
Sure, algebra. Okay, and then I want a tangent plane, right? Okay, so I need to remember about tangent planes that alternatively I could write a tangent plane as a local linearization, right? So that would be L of x and y, right? Which would be f at AB plus the, oops, that's the wrong symbol, plus some kind of change in x times some kind of, so close, times the,
Is it like the direction magnitude? And you're trying to like
so close, it's the slope, right, in the x direction. Right, so
Partial?
my best guess for this function, right, is the dumb guess, right? It's just the function value plus the change in x times the slope in x plus the
So fx of a b.
change in y, slope in y. And then I have to remember where I get slopes, right?
We could say this is analogous to point slope form, right?
Yeah, exactly. This is y is, well, really this is maybe more like, I wrote that too high to reach above it. This is like y is m times x minus x naught plus y naught. Right? Slope in x, change in x, and some kind of initial height, right? You guys all cool with that? All right. So let me write. So L of x and y should be, let's see, what's my best guess for the height? In other words, what are AB and what's f of AB? F of AB is z, right?
Yeah.
Which is 1, and the A and B are 2 and 3.
Alright.
You guys see that? Okay, so my best guess is, or my dumbest guess rather, is that it's 1. And then my second dumbest guess is to put in some kind of something and x minus 2. And then something and y minus 3. You guys all see that? This is the change in x, that's the change in y. Now I need the x slope and the y slope.
Okay. And that
So-
would just be the partial derivative, right?
Okay, so I'm going to do fx, right? But that, what category of object of that is fx? Yeah, that's a partial derivative, right? So it's a function of x's and y's. You guys all see that? But what do I want it to be? Yeah, I need this to be a slope, right? So that should be a number. So how do you get a number out of fx?
That would be
A and B, where A is 2, B is 3.
Good, yeah, you need to feed it a and b, right? And then this guy is going to be
Fy.
fy at the same 2, 3. You guys cool? All right, so what's fx? Oh, shit. Why am I saying, oh, shit? Yeah, it's a quotient of x's and y's, right? Okay. All right, so we want to calculate fx, right, as a function of x and y. So what do you need?
First, what's the function of x, y? That's just. So we have the function of x, y, and z. Oh, we figured out that there. Okay.
Yeah, so this is the function I'm playing with, right? I'm playing with this guy right now. And I need to hit this thing with a partial with respect to x, right? So this is fundamentally a quotient. Oh, shit.
Couldn't you make it everything on top times everything on the bottom? So
Yeah, you can just do a product rule.
Sure, yeah, you can cheat and use the chain rule and the product rule. Whatever. I don't care whether you know the quotient rule or not anymore. I'm going to use the quotient rule because I happen to remember that. So let's see, I need the derivative of the
Derivative top minus 3.
derivative of the top times the bottom.
Yep.
So what's the derivative of the top with respect to x?
Negative 2x.
Negative 2x, and then times the bottom, times the minus xy, minus the derivative of the bottom with respect to x is negative y, and the top's derivative with respect, oh wait, sorry, what?
the top has to be 7 minus x.
Just the top, so 7 minus x squared minus y squared. and then all over the
Bottom square.
bottom squared is x squared y squared. Okay? And then I need to evaluate this at 2, 3, right?
Yeah, I'm just be plugging.
Yeah, so you plug numbers in here. So you get fx at 2, 3 equals number 1. Whatever you get. I trust that you all can do that. And then fy of x and y is something. Do the same thing, right?
Yeah, spectrum.
Yeah, and that's probably symmetrical. You guys see that? So you basically did this problem already, right? Okay, so I'm going to assume that you all can do that. We're going to do 2, 3 and get a second number here. Then what are we going to do with those two numbers?
You put them in there where you're.
Trot them over here and put them right here. Cool? Okay. What are those numbers probably? Right? I know what they probably are, right? They're 4 and -6, give or take sign, right? You guys all see that?
Why would it be 4, -6? 4 is the y value.
Oh shit, 4 is the z, or 6 is the z. How about it's 1 over 6 and 4 over 6, give or take sign. That's better. That'll actually work, as opposed to that first thing. Crazy. Cool? So we could get that out of here. We could get it out of there too, right? It just takes longer. So which of these two approaches is better?
First one.
Probably the first one. It depends on how the thing is written, right? But if it's written as a level surface, treat it like a level surface, man. It's easier. Cool?